Students, again, I'm sorry I'm a bit late. I was held up in a meeting and guy didn't stop talking, so I had to. Today we are going to talk about the final exam, your grades, and what am I looking for? And we will have one presentation, project presentation, and then we will have 15 minutes for you to submit your evaluations, course evaluations, right? Whoever, I don't know if I've mentioned this in class before, but I think I have. Don't forget math. Whoever submits their evaluation and send me the receipt, just the receipt, right? Don't send me your personal information or anything, or your evaluations. You will receive an email if you submit your evaluation. Whoever sends me that receipt will get a bonus point. And yeah, I'm going to give you 15 minutes at the end of this lecture to submit your bonus points, your evaluations, and to get the bonus points. Today's, what else? Do you have any questions? No, about the bonus, about the projects. Graduate students project is extended to next Monday. If you're already done with the project, you can of course submit it. If not, if you need more time, you can enjoy the extra week. But your exam, let me change this camera position a little bit. Yeah, your exam is going to be on April 28th. So in 2 days at 4 p.m. I think it was in the email I sent as well. So in 2 days at 4 p.m. your exam, it will include everything we have talked about in class, which is the first five chapters of the aerodynamics book, the Anderson's aerodynamics book. And I will mostly focus on the things that we could not go over in the previous two exams, right? So final exam will definitely have a question from the Buckingham Pi theorem. Buckingham Pi theorem. We'll definitely have a question from potential flow theory. And we will have some questions from chapter 4 and 5. I will ask you, I guess we will repeat the questions. We have some of the questions we had in exam 2 as well. So, and you will most likely be asked to calculate the moment coefficient for a thin airfoil. Which I didn't ask you. And one more question for graduate students. Yes. There won't be any questions on the source panel theory. No, none. Yes.
Are those just short answer questions, or those also be like theoretical questions, like the beginning exam where we have like 5 short answer right now and answer the question?
These are not going to be short answer questions. No, these are the problems that you need to solve. Right? I mean, these are going to be problems that you need to solve. So as I think we have mentioned that your final exam is going to be, you're going to have 2.5 hours for your final exam to submit your answers to the final exam. And I really don't expect the final exam to take you more than 2 hours. Okay, there will be 3 questions for undergrads, 10 short answer questions for everyone, right? Or if I mean, I may give you multiple choice questions, but if I do give you multiple choice questions, there will be 20 questions, right? So each short answer question is essentially the same as 2 multiple choice questions, okay? And what else? Oh, there will be one question for graduate students as well. And about the grading, is there any question about the final exam questions? What we're going to include in the final exam? Do we remember Buckingham Pi theorem? Yes, we do. Okay, we have a couple of people who do remember this. That's good. What about the potential flow theory? Yes.
Is that with the vortex and the source flows and all that?
That's right. The elementary flow is essential. The vortex flow, the source flows. We don't have any questions on this topic for the exam 1, so it will definitely be included in the exam 2. We also had, we didn't have any questions on the lift and drag calculation in the wind tunnel. You may get a question from that as well. And also chapter 4 and 5 as well, you will definitely get one question. Yes?
How much coefficients in airfoil was just the other two that on the last exam, question 1?
Yep.
The other two
That's right. That's exactly right. Yeah. And okay, if there's no question about the final exam, what we can do is talk about the grading a little bit. I think we all already know that I will replace your lowest grade with your highest grade. Okay, let's say you have a 20 on exam 1 and you get a 95 on your final exam. I will replace your exam 1 grade with that 95, right? This was a deal from the get-go, I mean, from the exam 1, right? Are we all aware of this? Yes, some of you look very confused now, right? Yes? Okay. Yes.
Does it work in reverse? Like we did better on exam 1 or 2 and then do poorly on the final?
Yes, sure. Yeah, that's what I want to talk about. So there are a couple of people who did really well on their exam 1 and exam 2. To be fair to those people, I'm going to replace their highest grade on exam 1 and exam 2 with their final grade, which essentially means that they don't need to take the final exam, right? Does this make sense?
So essentially the final can't hurt us, like wherever we're at now, if we do poorly on the final.
That is the idea, yes. So because there's nothing new that we are covering in the final, right? So if you have done well in your exam 1, exam 2, this tells me that you already know a lot of material. Or if you have cheated on your exam, you are a good cheater. You're gonna end up cheating on the final exam again, and there's no way for me to catch you. I mean, there are a lot of ways, but we don't really do that here. And yeah, so the point is, you can do a good you can have a good final grade if you have already done well. So again, if you have done well on your exam 1 and exam 2, let's say your grade is a C and you're satisfied with a C. That works for me. It doesn't have to be an A, right? If your grade is a C and you're satisfied with a C, just send me an email, tell me that I'm satisfied with the C I have. I don't want to come to the final exam. Works for me, okay? Does this make sense? Yes.
That C, is that accurate on Blackboard? All the bonus points and everything are included in that, or should we calculate that?
Bonus points are not included. Okay, that's a good point you brought up. Let's talk, because I don't think I can show you the grades on Blackboard because everyone's information is on there. But the grades on Blackboard are the grades you have so far, right? If it says 60, that's 60% of the total things that you were graded on, right? I don't think anyone will say 60 at this point because most of you don't have your exam 2 grade. So it should hover, if you are getting an A in the course, it should hover around like 45, 50, right? Whatever the total grade. But that is excluding the bonus points, right? So let's say after I post the exam 2 grade tomorrow, that says 69, right? That total grade on the Blackboard says 69. And you have like 10 bonus points, right? Your final grade, if you don't take the final, will be a 79. Okay, and you will get a C+. Yeah. Do we have any questions? Yes.
I had another question about the exam.
Sure.
The first exam was open materials. Second one was just an equation sheet. What's the final like?
Well, that's a very good question. So your final exam is going to be exactly the same as the second exam. So just one two-sided, let me write it down. Just one two-sided equation sheet. With no explanation of any phenomena, right? And just the equations. Yes.
I didn't ask the last exam, but are we allowed to put relationships down? So like blank is a function of blank.
Like you want to say y is equals to f of x is
like stability is a function of
no. You are not allowed to put on any explanations on it, just equations. Yes.
Is that different from the last time?
It is not.
Oh, I thought the last time was.
Yeah, a lot of people included some explanations and definitions in their equation sheet. And I think I mentioned that you shouldn't do that last time as well, but I'm not going to penalize anyone if you did include any explanation. But this time for the final, don't do this, because I want you to be able to explain a phenomena, right? It doesn't have to be the copy of the book's explanation, but you have to understand. Like when I say downwash, what is happening there? I don't want you to just write down the words. Okay. Any other questions? Yes.
Will we have like a preparation sheet like we had for examination 2 for the final?
So no. And the reason is, I think I gave you example problems for exam 1 as well as the preparation sheet for exam 2. So if you just go there, learn whatever is on, there's nothing extra other than the things that I mentioned.
Okay.
So if you know this, if you understand all of the concepts and you study the examples I've solved in class, all of the homeworks, you should be able to answer any question. So there's nothing that I could add as extra material on the preparation sheet. Yes.
What was that exam 1 stuff? Was that on Blackboard?
I'm pretty sure it should be on Blackboard. We can check.
Was it like a prep guide or?
No, it wasn't a prep guide. It's just a couple of questions. So you didn't have any. Let me see. I'm pretty sure we had an exam 1 review. I don't see anything on Blackboard. I will upload some example problems on Blackboard because I don't see it here. But I remember we had an exam 1 review session and in which we solved some example problems and talked about the exam. Okay, so watching that lecture, I guess, is going to help, right? I don't think we're going to have any circulation problems on the final exam because this is something that we I don't know. I don't want to say anything about it. I mean, you already have had the question on that, and yeah, I don't think. I'm not gonna say it with 100% certainty, but I don't think we're gonna have any circulation problems on the exam 1, right? On the final exam. You are already tested on it, and most people didn't give me the correct answer. Yeah, so, any other questions? Yes. That's the attendance grade. I have to remove that. That's essentially the attendance grade. Yeah. Okay, so is this clear about the grading? Right. If you're already satisfied with your grade, You just tell me, just make sure to send me an email and let me know that this is the case. Because if you don't, then and if I grade your homeworks, I will usually give you 72 hours to complain about your grades if you have any issues with it. But sometimes, I don't know, you're going on a trip or whatever, you can't get back to me in that span of the 72 hours, then I will post the grade on your transcript. It will cause a lot of problems. So make sure to send me an email and let me know before the exam, so I have the correct grade. Right? Does this make sense? Okay. What else? Any other questions about the exam grades or homework grades? Yes.
So the short answer, you said it's not gonna be like questions, could it be like off the guide from, I know you said it wasn't like previous exam questions, but could it be off the guide from the second one? I guess.
Yes, it does make sense. So I don't think we had any guide for exam 1 for the short answer questions. If you think it's going to be very helpful, I can provide a guide for exam 1 part of the class as well. But essentially what I did, I went through all of the lecture notes and I gave you any question that I could ask you. Okay. So if you can answer all of those short answer questions on the exam 2 guide, you should be able to answer any question that I can give you. Does it make sense? If you think it's necessary for you to have something like that for exam 1, I can definitely go back and prepare something like that and put it on blank for you. Do you want to do this?
Yeah, I'm not gonna.
Okay, yeah, definitely. Any other questions? Okay. So attendance grade. I think that's the last thing we want to talk about. I gave you a lot of I guess I gave you a lot of opportunities to go back and watch lectures. Lectures are all posted on Blackboard, right? Or on YouTube, right? You all have the link to it. And if there was a lecture that we did have an attendance bonus or attendance quiz, right? And you haven't submitted it yet, then I have to say, I'm sorry, you will lose the attendance grade, right? There are a couple of people who are going to not get their attendance grade, right? So make sure, I guess the time has already passed, so. And if you think that any of your grades is unfair, please reach out to me before the final exam, right? Because it doesn't mean that if you reach out to me after the final exam, I'm not going to be helpful. I'll try to be as helpful as possible. But I guess it's a better idea to reach out to me before the final exam when I'm a little less swamped with other students, with other matters, and I also teach other classes with more students, so they're going to be talking to me as well. So if you want me to go through your grades as soon as possible and correct any possible mistakes, please reach out to me as soon as possible, okay? Do you have any questions about the attendance grade, about the bonuses, or about anything? Right. No? Yes.
So I see on here you have the attendance, and then you said you also have the pop quiz, which is also the attendance.
That's just an extra column. I will remove that. Yeah, I will remove it. No.
Is the attendance grade also is that multiple? Is that all of our quizzes, or is it just one?
All of your quizzes, all of them included, right? But I don't really grade the quizzes. So as long as you have submitted the quiz, you got 100 there, right? You got a passing grade. It's just a fail and a pass. And fail only happens when you don't really submit any. Do we need to solve an example from the Buckingham Pi theorem or any other? Are we ready for the final exam? Let me ask you this. Have you already started studying? A little. Okay, what about anyone? Just a little. Okay. I know there are a couple of you who I assume are not going to take the final exam unless they love exams, which is okay, right? No judgment, right? But okay, okay. If that's the case, then we can just wrap up the discussion on the exam. Do we have any questions or any comments about this past semester, about the material, about anything? I assume all of the undergraduates are graduating this semester, right? No? No? A lot of undergraduates are not. Who is not graduating? Okay, so this is your junior year then. Yeah, it was a little too soon for this course. But I hope you have had fun learning aerodynamics. I know it has been tough, but it is a tough subject, so there's nothing we can do about that. And let's do this. It's already 6 o'clock, and I thought you would have more questions, especially about these topics, but it looks to me that you are there. Don't remember anything about them. That's why you can't ask anything, or you know them completely, right? And but these two will definitely show up on your final exam, so make sure to go back and study them. And yes.
Can you tell us how many things there are for Buckingham Pi theorem? How many? Getting the exact terminology.
Variables.
Variables to use, like whether it's 5 or 6 or 7 or whatever.
I'm not sure if I understand your question correctly, but I will tell you that like pressure difference is a function of diameter, velocity, length, and what all of these variables, all of these other variables, give me the dimension as parameters you can use to analyze this problem. Yeah, that's yeah. You don't have to guess the variables. No? That's I guess as an engineer you should be able to guess those important variables, but it is very hard to test you on your engineering perspective in an exam, right? Hopefully you will be tested on your job. Right?
I think I remember going over it last time, and you said there's like 4 or 5 that were like always there. Just about like speed of sound and stuff.
Yeah, in aerodynamics, I guess the speed of sound is usually present. Yeah. I mean, there are a couple that are mostly present, depending on the problem, of course. Yeah, but you will be given those variables. Any other questions? No? So let's do this. Which one do you want to do first? We can do the evaluations first. I can give you 15 minutes for the evaluation. If you feel more comfortable, if I leave the classroom, I can leave the class. If not, I will stay here. And we can talk, and then you can submit your receipt to me, and then we can do the presentation from one of the groups, Mohammed and Paul, right? They have done a pretty interesting study using our wind tunnel and their own something they manufactured, right? They made. Which one do you want to do first? Their presentation, okay. We only have one vote, but I guess you would. We only have 2 votes. Okay, so come on up, guys. Let's start this. And if you are, let's do this. Can I borrow a paper? Just a paper. Can you just tear out the paper and write down your names on this? This is going to be your last attendance. I guess check, but this will be just a bonus for people who have attended, right? Do you want to use your own laptop?
Yeah, I mean, I already have it pulled up here.
Sure, yeah. I'll put in. I don't know if you know. And whoever asks questions will get bonus point. Whoever asks questions will get a bonus point, okay? And if your question is interesting enough or challenging enough, you'll get 2, let's say 4 bonus points, right? Yeah. What's that?
You're only kidding. You already have their grades.
I'm not kidding, no. Be as challenging as possible. Yeah. Just have to move that to your laptop right here. Yeah. And so they have 12 minutes to talk, but since we have a lot of time, we can go more, and then we'll get some time. I guess you need this mic as well, guys. Just have to use this mic.
It's right before the results.
I'll just come in.
Hello, everyone. So I'm Mohammed. This is Paul. We are teammates, and we have been working on a system or a model on which we could mount an object. It could be an airplane, it could be anything, but typically it's an airplane. And you could like change the angle of attack and use the load sensor in the wind tunnel to find the drag based on the change of angle of attack. So let's recall rather some concepts and get touch base with it. So we know that the drag changes with the angle of attack. Actual lift changes also with the angle of attack. We have studied the lift versus the drag, lift versus the angle of attack, drag versus the angle of attack graphs, and we know that what the general trend is. And we also know that the real conditions may be simulated in mental and the behavior. We did a couple of questions, maybe two questions in homework 1, and I think one problem in the class. So we know that real conditions that the airplane experiences, we can simulate them in the wind tunnel. The condition in the wind tunnel must be calculated for the flows to be similar. So the flow have to be similar geometrically, and the object should be geometrically similar, and the flow should be dynamically similar. And once this similarity is achieved, you should be able to get good results in the wind tunnel. So the model to be tested was a 150th scale Beechcraft Bonanza V35. It's a 150th scale, so we have the geometric similarity. And just a couple of things about the model: it has an 8-inch wingspan, which is like this big, and it has a 6-inch dihedral angle, which imitates the actual airplane. Which it also has a 6-degree dihedral angle. It's a low winger, rectangular tapered, so it's not swept back or swept front. It's a rectangular wing, and mounted under the fuselage and tapered to some NACA profile. And it's famous for its like V-shaped horizontal stabilizer. Usually, the tails of airplanes are like horizontal and not like V in shape. It's famous for that. So we need to we have attained a geometrical similarity by we have a 1/5 scale model. For flow similarity, for dynamic similarity, we had to look up what the steady speeds and steady height of the airplane was. And so a couple of some research, and then you find out that steady state velocity. You could do it on a lot of velocities, air speeds, or whatever you want to do. But we chose 70 knots at 15,500 feet because that's the flight envelope for the Beechcraft. And the 70 knots being because this was under the limits of the wind tunnel. So the Beechcraft cruises at around 165, 160 knots, which is like 20,000 feet per minute, and the absolute limit of the wind tunnel is like 19,000. We don't want to push that. So 70 knots is about roughly speaking, when you like find the floor similarity and everything, your velocity of the wind tunnel comes out to be 8,000 feet per minute, which was still pretty high when you like turn on the wind tunnel, but yeah, it's okay. And so the actual experiment, so we did 7 experiments ranging from -10 degrees and then to -5, then 0, then 5, 10, 15, 20. So -10 to +20 degrees with 5-degree increments. So we had to calibrate the, we did calibration. We had to calibrate the load sensor before every experiment had to be performed. And so the model, you'll see the picture at the end. So the model itself is a really big model on which the airplane is mounted. So we initially did the drag calculation for the model only, and then when the final values came in, so we had to subtract the airplane, the total drag values from and the model drag values to get the drag for the airplane. Is that you? Yep.
Okay, so these are our results. As you said, we did in increments of 5 degrees. The mechanism we made is able to do increments of 2.5 degrees, but in order to save us some time, we decided to go with 5. Is that one of the like smaller flaws in the mechanism that we made is that you have to turn the wind tunnel off. So in order to change the angle of attack, so just to add some extra time for the experiments. So we chose to go by 5 degrees mainly for that reason. And this is kind of just our gathered data from us like running the experiments. And I added in like the times that we were recording at, so we'd kind of have an idea of like how long we actually had to like sit and wait for the wind tunnel to normalize. Because like once you change the speed value, you have to like sit and wait for a few minutes in order for it to be entirely stable. So that's why I recorded some of that. And I noticed with some of our calibration data that like the time completely affects your like voltage readout that we get off of the sensor, especially when we're doing like the hanging weights for the calibration to see how much force is how much voltage difference. That one is very time dependent. Like I sat there for like 2 or 3 hours at the same amount of weight, and the voltage would change relatively drastically over that amount of time without me changing the weights at all. But we didn't notice that issue as much with this. So we stopped waiting as long as we noticed that like after like 2 minutes it would sit relatively stable and the voltage would not drop like as we were having before. So I think that we need to come up with a different like weight calibration method, because I think it has something to do with the swinging of the weights, like when we go and hang them to calibrate that sensor. Like it just has a huge variance in the amount of force that's actually being placed on it. So this is our CDS versus alpha graph, and we decided to go with CDS because we didn't have a great way of measuring the S on our 1/50th scale model. And we figured that we could calculate Q infinity and that the trend itself would be the same whether or not we included that S. So for a comparison to the aircraft itself, we would need to do the calculation of the S. But for the purposes of the trend and seeing if our mechanism is actually giving us the kind of data it should, this works. So you can see from -10 on the left to 20 on the right, and the actual graph of CD versus alpha looks fairly similar to this. It has like a dip, like a parabolic dip, and then it goes relatively linear. And you can see that we have a couple of dips in our line. It's not entirely linear, and I assume that's a lot to do with like the error in our setup in some of the voltage readings. We also noticed that the way the wind tunnel's set up, you swing down the whole model in order to put it on, and then you swing it back up. So there's like a pin mount for that, and that's like super loose. So you notice that if we put like shims in there in order to keep like that gap from separating so it's not vibrating so much, that we lost a lot of that like extra air too. So some of it could be coming from that with that error. But for our conclusion, it proves that our mechanism does work. So we did get a trend that what we essentially wanted to see for our drag versus alpha. And here's the model itself, and I can talk about the design of it a little bit more. We decided to go with like aluminum extrusion framing on it, just for ease of assembly and manufacturing, because it was super cheap to use that stuff essentially. And we 3D printed 2 angle brackets essentially, and they have holes every 2.5 degrees. And you can't tell from this photo, but there's actually notches every 10 degrees as well. So you're not just staring at like, what is this one? Like you can't really tell from that. So there's notches every 10 degrees. So go, okay, this is 30 degrees. You don't have to sit there and like try to count and everything. Yeah, so this whole plate on the bottom swings down. I don't know how many of you have had to do lab 3 and actually had to do this. Yeah, so that thing swings down. That's what I was talking about. Essentially, this whole wooden plate wants to like shake up and down. So that's been an issue for some of our stuff. But you can see the Beach Bonanza model mounted on the front. And all you do is pull the bolt out from here. It has a wing nut on the back of it, and it's pinned in the center. So then you just rotate it over and pin it back up. And we were limited in our Z essentially on the bottom. So we only went to 30 degrees for the positive angle of attack, and we went to negative 35 on the top. Questions? Yeah.
For your CDS versus alpha, do you guys calculate the slope? And if you did, like, what's the relevance of the slope, like compared to like CL versus alpha?
The relevance of this slope is not important here. The reason being that we know that the trend we get is true. We know that the values are not true. What it means is basically that the actual, even if you do it on like on an accurate pinhole, you would do experiments on the same model, you'll get really different values. The reason being that firstly that the Reynolds number was really low. So the usually at 20 degrees the aircraft would stall, but it kept increasing. You would see a sharp. It's not a straight line. It's usually a sharp. You know, the graph turns up into the y-axis at some angle when the aircraft starts to stall. But over here it's kind of linear. So the finding the gradient would not really have any significance. So it doesn't really matter.
Before you answer other question, where's the paper? Can you pass it here? I'm gonna write down the names of people who are asking questions.
Let's do a head count. That's the
So, you guys couldn't use the CDS versus alpha to find S.
Define.
Kind of roughly knowing what the drag coefficient would be with alpha.
So CD is like drag over half Q infinity S. So S is like the total, wingspan or area, whatever it is, like the total area of the airplane, like everything combined, like fuselages and everything. We don't have that data.
Yeah, we could only, and even for what we could find online, we could find the CD at alpha of 0 lift.
Yeah.
But we didn't know where that was either.
Yeah.
So that wasn't particularly helpful for us, because if we know where that was, then for my calculated CDS, like I could have like potentially figured out, okay, this is probably what our S is. So, but yeah, because we just don't know where that is. So I had thought about doing that earlier, but
Got one over there.
So the only note that the wings were attached like under the fuselage, how would your results have been if they were more centrally located?
I Couldn't hear what she said.
She was talking about the location of the wings for them being lower. What the difference would be if there'd be like a mid wing instead of like a low wing for this.
We would get typically the same trend, but maybe obviously the values would be a lot different. Again, low wingers, mid wingers, high wingers. We have covered that in the topic. It depends. There's no like the best design for this is a low winger or a mid winger. There's nothing like that. So you could have like a high winger, a low winger, or a mid winger, whatever is cheap and good for maintenance. So like high wingers has a problem with you have to for maintenance personnel, and for low wingers it's kind of easier. You don't want to have that much height on it. And then for low wingers or mid wingers, you can have a dihedral. High wingers usually have an anhedral. It's all a mix and match. There's no best design competition that the low wingers win or something. Okay, go ahead. I guess I'm gonna start from there.
So, understanding of this experiment.
You're gonna have to speak out loud.
So my understanding of this experiment is that you all were essentially getting validation when it comes to the different angles of attack on a known shape, like a known aircraft.
Yes.
Okay, so based on that, from what I understand about the experiment, this would be a mechanism in somewhere in the fuselage itself that would change the angle of attack based on the conditions that the airplane is in.
It's it's under the fuselage actually.
Under the fuselage.
Yeah.
Well-
So how would you mitigate the complexity and the weight of the aircraft so that you would have a better, I guess you could say, higher load capacity if it's like an AC, like an AC-130 or one of, a C-130, which is like one of the transport planes that they have in the military. If it were a cargo plane, there we go. How would you how would you reduce the overall weight so that you wouldn't have to be affected by the losses of the system weighing so much, which would reduce the load that the plane can carry?
Well, if it's a cargo plane, that's actually in our benefit in the sense that these passenger aircraft, they don't. So you could see that this bolt, this pin, it goes in there. So in an actual passenger aircraft, you don't have that bay. But in a cargo airplane, you do have that bay. So it could be an advantage. It could replicate the actual airplane model in a better way. And this would, I'm guessing it's gonna be a rather more accurate um, experiment. But again, as I said, like accuracy over here was not the ideal standpoint of the experiment. It was just to have, just to see what the what the trend we are getting of a certain airplane. Okay, yeah.
I thought your experiment was really neat because you actually built something. Did you go into this project with this in mind, or did you want to change the angle of attack, realize we couldn't, and then fix that problem?
It was actually Professor Mobley. He pointed out that we need a device that needs to change the angle of attack. We had a couple of. So initially, we were supposed to do 3 experiments. This one is for Beechcraft, Bonanza. Then there were 3 models. There are 3 models actually. The other one is the P-51 Mustang, and the third one is the F-16. So this was the best choice because it has a steady cruise velocity data that's online. Like you can't find it for F-16, and for the P-51 Mustang, it's just a fighter aircraft. And so like fighters don't have like a steady state velocities. They're like high maneuverable, works at all velocities apparently. And so he wanted some device that could maybe change the angle of attack of the models and see how that trend transforms into a graph or something. Okay, you had it, man. All right, go ahead.
Let's wait for the after the class.
did anything that would have made it easier for you, or if you had more resources at your disposal.
I definitely would have liked to redo the bottom mounting method, because essentially what we did was they originally had a car in here before, and we took the mount that the car was on, we took the car off, and we said, okay, what can we mount to this that we can mount the planes and then also change the angle of attack. But it would have been, I guess, more ideal if we could have changed like this whole bottom plate that I was talking about that vibrates up and down. It has like the way the load cell is set up on it isn't great either, because you're essentially counting on the deflection of that rod. It's a tension gauge, and the rod just moves, so it just deflects and it pulls on that gauge. So it's not like the greatest method of trying to find that drag. It would be more ideal to take like a multi-axis force sensor and stick that just on the bottom of it instead of having like the single axis load cell. But yeah,
I've never been down there before. They changed the curriculum by the time I got to last week.
gotcha.
So on your results page, you guys had set a voltage value on there. I'm just confused, like what the voltage is and like how that works into the calculation of CP.
So the load cell that we have is uncalibrated. So it doesn't come with any kind of data of like what force is my readout. It just essentially just has like a tiny little strain gauge in there, and it's hooked up to a voltage reader, and it's just reading the change in voltage that we have like over time. And we only have like an analog readout of that as well. So we have to like physically like read it and then type it down. We don't have like an active computer like DAC system like recording this data for us or anything like that. So we just record the voltage directly, so we could use our other calibration data, which isn't shown, which is literally just a graph of like a ton of voltages like over like period of like 3 hours with like 40 different like weights hung on the cell in order to try to get like some kind of idea of like what does this voltage actually mean force wise, and it's about the difference. So like normally we were seeing about 40 volts for just stagnant, like just sitting still. So it gives you a little bit of perspective. So like, okay, so 45 volts, you're looking at like an increase of some amount. Eventually, I came to like the conclusion of about 10 volts was about 5 pounds of force on it. But yeah, that's why. Yeah.
Did you guys like choose the Bonanza model for a particular reason, or like did you make it, or did you buy it, or how did you do it?
It was already there in the internal. So there, as I said, there were three models. One was the F-16, and then there was the P-51 Mustang. Then there was this Beechcraft. So this is like a passenger aircraft. You know, you have a steady cruise flight. In a fighter, you don't really have well, you can cruise, but you don't have like any cruise conditions. Or obviously it is designed for some conditions, but it's not generally published or something. So data for F-16 was like very difficult to find. Whatever data we found for the Beechcraft was not available for the F-16 or for the Mustang. So this was the obvious choice. Yeah, go ahead.
So I see that you have like all the different like angles for the that you use, but then you have like the mount only, and so I'm just wondering why, if is that like without the model, and then also if it is, how come you have the different angles of attack for it if it's like without the model?
So he's asking about our model only calibration data. So essentially the idea was that in wind tunnels you have some kind of like blockage ratio typically, and that can create a lot of drag, especially with the mount itself. So we're essentially trying to find out is how much drag are we actually creating just from having this like the mount itself in there, because we need to figure out how much drag the aircraft itself was creating, not how much drag our mount was creating. So we had to do that difference, and because of the way this center pole is, I wish we had another picture of it, but essentially the whole thing rotates up and over. So you have this center rod that is now at an angle also in the wind tunnel. So essentially we have like another small thing that's also changing the angle of attack, which means the drag for the mount will also change with the angle of attack. So that's why we had to do calculations for the angle of attack for just the mount itself. It's just changing that. So like we put it up, 20 degrees and then calculated the drag. Then you stick the model over there and take the difference of those two.
Okay, let's go with Matthew, and there's also an online question that's right over there on the laptop. Let's do Matthew first, and then we'll do the online question.
Zach, on your results slide, I just had a quick question. I was wondering, when you wrote time, is that time in hours or minutes?
It was minutes.
Okay.
Yeah, I should have written that on there.
No, I'm just curious. And also with the velocity, like I know that's tough to kind of stabilize the velocity in the wind tunnel. So like what steps did you do to help stabilize and make sure you're getting readings at the velocity you wanted?
Essentially, I had my stopwatch out the entire time. So the second we started the wind tunnel up, I'd start my stopwatch, and then we'd go through and we'd change the dial and get close to what we were aiming for, which was 8,000, and then we'd like wait a minute and then change it back, and then we eventually got like pretty good at like, okay, like right about here on the dial sets us at about 8,000. So like after a couple of times of doing it, like it wasn't so bad.
Let's do the online one, and then Jacob last one, okay?
So Roland is asking, what effect do you think the vibrations from the rig affected the analysis? If it were more stable, do you think there would be a different result? I guess not. All right. So he's asking if vibrations did any impact on the microphone. He's asking if the vibrations had any impact on the results. Initially, we also thought that the vibration, because that thing vibrates a lot. So we also thought that the vibrations would, impact the results pretty harshly, but it kind of didn't. It all depends on the accuracy, the build, the filters that are in the load sensor, because the filters are supposedly there to cancel out any irrelevant signals like vibrations, and then also the sensitivity of the what do you call that sensors?
Strain
Strain
gauge.
gauges. Yeah, the accuracy of the strain gauges, and yeah, so that's it. So if well, we initially started out, and then we thought that the values of the voltages will maybe jump up and down a lot, but it kind of didn't. Like you give it like 2 minutes, 2.5 minutes, it would get stable. Maybe change with like 0.01 volts, but it was still pretty nice. It was pretty neat. So at least with this load sensor, I guess the vibrations was not as much of a hurdle, because if that which kind of brings us to the point that the load sensor is not really sensitive or accurate, because if it would be really accurate, it would like jump up like crazy. But yeah.
Let's do the last one. Let's do a quick answer to this question.
Okay.
So I know that you built your plane to a 1/50th scale. Did you also translate that into weight, or what was the effect of making it
I don't know. We did.
heavier or lighter than the model?
Yeah, we did not make the planes. These were bought by. He would probably more professor would answer it.
Yeah, that weight is not very important in your SQL here. Okay. So thank you. Just one comment. I think that's going to. Can I have?
Yeah.
One comment that you want to take it now. One comment that is going to be, I guess, beneficial to all is that let me just give me 1 second, right? Yeah. When you are presenting experimental result, you should not present it as a line, because you have not measured like 3 degrees, right?
Yeah.
You have only measured 0 degrees, 5 degrees, 10 degrees, 15, and 20. You don't know what is happening in between. You can present a trend line, like with dashed line or whatever, but you should not have a straight line, right? Just for all of you, I think that's something, especially if you're in the graduate school or planning to go to graduate school, experimental data only should be presented with a with just points. Okay, thank you. Very good presentation. And this brings us to the last thing we want to do today. I want to give you 15 minutes to fill out the evaluation, submit your evaluations. And if you don't want to do it right away, you can leave the class. You don't have to sit through this, but I just want to make sure we dedicate some class time to the evaluations. Okay? Just a receipt, yeah. So they will send you a receipt that tells you that you have submitted this. Just a receipt, yes. I mean, I don't care about the other courses, so don't do that. Don't do the rest of them, right? If they're not giving you bonuses, why do you want to? Or do them and give them all once. I'm kidding, of course. That's for the record. Don't do this. There was one question. I saw one. Yes.
Is there any thin airfoil theory? Like there is for coefficient of lift versus angle of attack. Is there one for coefficient of drag versus angle of attack? Since they're so related.
Thin airfoil theory. You mean like we usually did represent drag coefficient versus angle. So let me put this way. For lift coefficient, it is usually presented with CL versus alpha. For drag coefficient, it's usually presented with drag polar, which is CL versus CD. How much drag you're gonna get while you produce this much lift, right? Pardon me? Yeah, because they don't have any way of calculating lift using that setup. That was the only thing they could do. What do you mean by similar? So no one submitted their evaluation. Okay, that's all right. Go ahead. Well, so is it similar? Is that your question? It shouldn't look similar if that's what you're asking. Yes, just forward it to me. Yeah.
For their graph, have like a similar kind of fall off with like.
No, that
starts
actually
low.
it should look something like this. They didn't get the stall condition. The idea is during a stall, your drag increases, right, rapidly.
instead
So
of
it
falling off,
should look
goes
something like
exponentially.
this,
Gotcha.
and it doesn't go to 0 here or negative.
Yeah, I guess that's what I was gonna kind of wonder is if there's a thin airfoil theory for coefficient of drag versus angle of attack, where there's like normally it does this and theirs did like this or something like that. Like what's gonna be?
Are you asking whether there's an analytical solution for it?
Like, is there ideal? Like, there's ideal CL versus alpha.
That's not necessarily ideal. That's the best.
Thin airfoil theory, where it's like
That's not necessarily
it's
ideal, though.
symmetrical and if
Thin
it's-
airfoils are not going to give you the best.
Ideal
lifts.
as in most generalized, most idealized, not like
I can't
the
think of.
best
I
conditions.
can't really. The thing is, you can calculate drag. You don't need to do any. You don't need to have any simplifications like you do with lift, right? Like friction coefficient, right? You can already do that, right? You don't need to come up with a thin airfoil, right? Does that make sense?
So there doesn't exist. Any
I'm
thin
not
airfoil
aware of
theory
it.
for drag?
I don't want to say it doesn't exist, but I'm not aware of it. That's the best answer I can give you.
Okay, so there's nothing really to compare.
And with your thin airfoil theory, you can actually calculate drag,
Yes,
right? So it does exist in a sense, I guess.
but there wouldn't be a chart like this for drag coefficient versus angle of attack, where
That this is not a chart that is for thin airfoil theory. That is a chart for any airfoil.
yeah, but it has. So it's like comparing them to thin airfoil theory. So it's like it has, like theirs would be something like this, and then they would also have thin airfoil theory. So they're like, this is how it differs. And I was wondering if they had something like that for.
Oh, like a standard. So you're
Yeah.
asking whether there's a standard drag, right?
Yeah, yeah.
Okay.
For like, I would assume it would be for thin airfoil because thin airfoil
Why
is like
would
the
you
most
assume it?
simplified thing. Like,
No. So let me actually see if there's. Let me I didn't record this lecture. Let me leave this.
Oh, there's the camera. You say professor.
You didn't know? Yes.
You stole my pencil?
I'm sorry. I